Assalamualaikum and hi everyone. My name is Muhammad NASRULHAQ bin Muhammad RUDZI. We are from Group 9. So my group will decide to do a gas turbine power plant. So I will take the part of this description of this application. So the first part is about the gas turbine power plant is the most satisfactory power developing unit among the various means. They are producing mechanical power due to its exceptional reliability, freedom from vibration, and the ability to produce power from comparatively small size and weights. Okay, the second point is about the gas turbine power plant. It's a combustion engine that have a head of a power plant that can convert the natural gas or other fluids to mechanical energy. So this energy can derive a generator that produce the electrical energies that move to along power lines, homes, and the business part. Okay, for the next part, I will explain about the simple diagram of the gas turbine power plant. So the first part, air will intake from the atmosphere through to the filter that going through to the compressor. So after this process, the fuel or air will mix into the combustion chamber. So what I have learned before this about the combustion chamber. Combustion chamber is the part of an internal combustion engine that air and fuel were mixed to burn it into the combustion chamber. So after this process, they were going through to the gas turbine. So this gas turbine is a open cycle system that have inlet and outlet. So after the gas turbine were working, the coupling were moving to move alternator that derive mechanical energy to starting a motor. So that's all from me. Thank you.
Hi, my name is Kang and my matrix number is 306988. For my part, I will be talking about the first and second law of thermodynamic, which relate to our application gas turbine power plant. So first, I would like to start with first law, and before we start digging deeper, I'd like to explain how actually the gas turbine function. So let's just have a look. So what happened is the air from surrounding is entering the compressor and being compressed, and the compressed air later will be mixed with the fuel in the combustion chamber and create a high pressure, high energy gas, which will drive the gas turbine, the turbine shaft, to rotate. Here we can see that the first law is applied where, first we can see the combustion chamber, the heat energy is produced here, and later it will be transferred to mechanical energy as the shaft is rotating, the turbine is rotating. There is the mechanical energy, we can see that. And normally a gas turbine is connected to a generator or an alternator, depends on what current you need, AC or DC. So the mechanical energy will be transferred to electrical energy by the generator or alternator. Okay, next I will be talking about the second law of thermodynamic related to our application, gas turbine power plant. So basically, it is all about energy is directional and irreversible. So as we all know, there is no such thing as 100% efficient machine. So most of the power plant, a gas turbine power plant, is connected to a boiler, which the boiler is then connected to another steam turbine. So there is a much higher efficiency in producing the energy, the electrical energy. So you can see from the example, the second law of thermodynamic is applied where the heat energy produced by the combustion chamber is transferred to the boiler. And we can say that at the combustion chamber or the outlet of the gas turbine, the energy is high. It has a higher energy than the boiler, where the boiler have a lower heat energy. So it's follow the second law of thermodynamic, and it is directional and irreversible.
Assalamualaikum. My name is Muhammad IKRAM IDRIS and my metric number is 205633. Okay, for my part, I will explain about thermodynamic analysis involved in the application. There are two types of gas turbine power plant. There is open cycle gas turbine power plant and closed cycle gas turbine power plant. The working principle of the gas open cycle gas turbine power plant, we can look at the diagram of the open gas turbine cycle. When the fresh air enter the compressor at ambient temperature, where the pressure and temperature increase, next the high pressure of air enter the combustion chamber when the fuel is burned at constant pressure. Then the high pressure gas enter the turbine where it expand at ambient pressure and it produce work. From the open cycle gas turbine power plant, we can make analysis by using the TS and PV diagram for ideal Brayton circle. So we can make the analysis and we can get the thermal efficiency of the Brayton circle and find the pressure ratio of it. So next, for the closed cycle gas turbine power plant, the closed cycle gas turbine works on the principle of Joule and Brayton circle. The working principle of it, we can look at the diagram of the closed cycle gas turbine power plant diagram. Okay, the gas compressed isotropically and pass through the heating chamber. There is the heating chamber. Then the heating chamber, the compressor air is heated and flow through the turbine. Then the gas in the blade of the turbine pass to the cooling chamber at constant pressure. Then the gas at the cooling chamber is flow through again to the compressor and repeat the process again. So there is a closed cycle open gas turbine power plant also make the analysis by using PV and TS diagram. So by using the analysis PV and TS diagram, we can find the work done by the turbine and the work done by the compressor. I think that's all from me. Thank you.